Okay, so this is presentation of chapter 4, which is about network access and networking media. And we will divide this chapter into 4 different subsections. The first is about the network or the physical layer protocols. Then we have the networking media, the different types of media. We have the data link protocols and the media access control. And I will do these 4 different sections in each 4 different recordings. So let's just start by looking at the physical layer. And if you have, for instance, a router at home, you will see that you will have different types of interfaces, and you can connect different types of media into your router. It could be an internet connection, which could be like a cable like this, or you can have a fiber optical cable. You can have a built-in switch where you also connect these copper cables, and you can have a built-in antenna for the wireless connections. So typically, home routers and home devices will cover more than one type of media. And all these media will tell you exactly, of course, what kind of a cable type that you will use, but also how the communication is sent out on the different types of media. When we are connecting wirelessly, there are, of course, other things we also need to look at. If you are at home and you're connecting through a wireless device, you probably only have one. But for instance, here at the school, we need to make sure that we have wireless coverage all over. So we have to have a bunch of access points connected so that there will be no holes or no gaps between the coverage area. And then we need to look at other aspects. We will come to that when we are looking at the wireless connections. But on the physical layer, this is where we send out the bytes or the bits. And they are sent out as different types of signaling depending on what kind of a cable we are sending it onto, or if we are using wireless connections. But here there are zeros and ones, and they are encoded into different patterns so that we understand what is a 0 and what is a 1. When we are looking at, for instance, using copper cable, we are sending the information out as electrical signals. So typically it's like a high voltage or a low voltage, which is a 0 and a 1. It could also be, when we go from high to low or from low to high, could also be how to encode a 0 and a 1. When we are looking at fiber optical cables, it's typically pulse or no pulse. Pulse is a 1 and no pulse is a 0. When we are looking at wireless connections, we have different types of encoding also. It could be the amplitude, it could be the frequency of the waves that we are sending out, and it could also be the phases of the signals that we are sending out. But these rules are described in the protocol that we are using on the physical layer, so that we're sure that we understand what is a 0 and what is a 1. This is actually what it's all about on the physical layer. And there are these different standards that make these protocols. The ISO has given us standards for the copper cabling and the connections here, the RJ45, for instance. We have the different standard organizations which gives us the different protocols for fiber optical transmutation, and also the IEEE, which has given us all the different LAN protocols. And within these, there are protocols for how to encode zeros and ones on for instance, a copper cable like this. When we're looking at the copper cables, it could be like this one here, which is a UTP cable, unshielded twisted pair cable. When we are sending data out on this one, on our local area network, it's done according to the Manchester encoding, which is where we look at the middle of the bit, and if it goes from high to low, then it is a 1. If it goes to high from low to high, it's a 0. It could also be an encoding called non-return to 0, which is just different in the voltages. One voltage is 0 and another one is 1. And there are other types as well. On Ethernet, where we are using these cables, it's typically Manchester encoding. We need also to think about whether it is synchronous or asynchronous, depending on whether we have a clock signal on the cable. And in normal LAN technologies, we don't have a clock. So we need to send something out telling the receiver that now a data packet is coming. We don't have a clock signal always saying ding, 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 now you can send, now you can send, now you can send. So here we just have a bit pattern saying, okay, now there is a packet coming. And then we know that we should start listening. And then in the end it says, now we are ending. And that's typically what we are doing in asynchronous communication. When we are looking at the fiber optical cables, which could look like this, for instance, well then we have either light or no light. A pulse equals 1 and a no pulse equals 0. And we have different types. We will look at that in the next section. And in wireless media, well then we have different types of how to modulate and how to encode zeros and one as well, depending on what kind of a protocol, whether it's 802.11a or G or AE or whatever we are using. But basically we are just sending it out as radio waves when we are using that. Another thing to remember when we are talking about network communication is the whole idea of bandwidth. The bandwidth is more or less like the speed of how fast we can send information. And that depends also, of course, on the different types of cables that we are using. We always measure the bandwidth in bits per second, and we have kilobits per second, which is 1000 bits per second. We have megabits, which is 1 million, and so on. Gigabit per second is 10 in the power of 9 bits per second. Terabits per second is 1 in the power of 12 bits per second. When we are talking about bandwidth, it's typically the theoretical bandwidth, because when we actually measure it, we will see that the throughput, which is what we actually get, is typically lower than the theoretical bandwidth. And that is because, of course, there could be things that influence the bandwidth. For instance, if we are more than one using the same connection, or if there are some things that influence it and some things that create problems on the cable, for instance, which interferes with the cable somehow. So normally we don't have exactly what we should have, and that is called the throughput. We also have something called the goodput, which is the actually data that's sent through when we take away all the overlay of what we are sending of extra information just to control the connection. But we can see, if you look behind on the back side or on the front side of our different devices, we will see that we can connect different types of cables. We can have Ethernet interfaces where we connect physical copper cables like this. We can have USB, we can have different serial interfaces and so on. So depending on what kind of a device we have. I've got one, this is just an access point where we have an Ethernet connection, and that's it, nothing more. And then we have the switches on the back side here where we have 24 ports and a gigabit port, for instance, and so on. So depending on the devices, we can see how many different types of connections that we can connect to them. And that's it. That was the first part.